Let's go over a couple of methods for solving quadratic equations, beginning with the fact here at the top. If x squared is equal to a number, then you get two solutions. X is equal to the positive square root of a, and x is equal to the negative of the square root of a. So maybe just to even check out a couple of examples with that. If x squared is equal to 9, you can even just think about why this fact is true. If you put 3 in place of x and square it, we'll certainly get 9. If you put negative 3 here, well, you'd have to square the negative and the 3. Squaring a negative would give you a positive 9 as well. So if you believe that this fact is true, it's essentially saying you're taking the square root of both sides, square rooting the squared would give you just x, the other side would give you 3, provided that you put this plus or minus in front of it to say there's two solutions. And it might not work out perfectly that you get an integer. You could have something like maybe x squared is equal to 7. What are the solutions here? Again, you could say, all right, I'm going to take the square root of both sides. On one side you have x. The other side you'd have plus or minus. And the square root of 7, well, you can't simplify that any further, so you'd have to really leave it just like this for your exact answer. And one other issue that you could have is, well, what if I had x squared was equal to a negative value, like negative 4? You can still apply this property. It would still give you x on one side, plus or minus. And here, if you take the square root of 4, you do get 2. But since there's a negative under the square root, if you were to type that into your calculator, it would give you an error message. Our way of saying that is the answer is imaginary. You can just replace the square root of negative 1 with the letter I, and this indicates that there's no real solution. So using this fact, I just wanted to look at a couple of simple examples first. Let's use these ideas in example 1 to solve these couple of equations, starting with this one here at the top. How could I use this property to find the solutions of this equation? The goal is to isolate the x squared, because once you do, you can take the square root of both sides. I'm going to start by, I guess I'll add 71 to both sides. In doing so, my equation is now 2x squared is equal to 72. Great. But before taking the square root of both sides, I want the squared portion by itself completely, so I'm going to divide both sides by 2. In doing so, I get that x squared is equal to 36, and it's at this point where you can say, okay, I got the x squared portion by itself. I can now take the square root of both sides. On one side I'll put x, provided that I put plus or minus the square root of 36 on the other side, which is 6. We're condensing this, but we're basically saying there's two solutions. There's x is equal to positive 6, and there's also x is equal to negative 6. I think it's fine to leave your answer just like this, but it is worth pointing out that this means there are two answers to the problem. So let's try this again, but looking at this one. There's kind of a problem because, well, it's not just x squared, but it's x plus 4 and then squared. How could I deal with this? So I'm just going to write this so it's a little bit larger, but we have x plus 4 squared is equal to 5. So unfortunately, you can't subtract 4 from both sides of the equation because this 4 is trapped within the parentheses. But you can apply this fact to something more complicated than x, provided that the whole thing is to the power of 2. So my first step will be take the square root of both sides. The end result is if you square root this squared, it just leaves you with everything in the parentheses that's left over, which is x plus 4. On the other side of my equation, I'll put plus or minus. Oh, and it can't be simplified because it's the square root of 5. So the difference here is we're not quite done yet because x is not by itself, but that's a pretty simple thing to do. I can subtract 4 from both sides. I have x now by itself. Negative 4 and a root 5 are not like terms, even though they're both numbers. The best way you could write it, to combine it, is negative 4 plus or minus the square root of 5. So this is again saying we got two solutions. X is equal to negative 4 plus the square root of 5, and x is equal to negative 4 minus the square root of 5. So that is it for this problem, but just the point being, you can still take the square root of something squared provided that this entire thing is in parentheses. The other method that I wanted to go over is something called completing the square. Same ultimate goal where we have this equation that has an x squared in it, and I'd like to solve it. But the issue is, I can't just solve for x squared by subtracting this to the other side because I have this x, and I don't want this here if I'm going to apply that square root property. What completing the square is going to do for us, it's going to get rid of this x just hanging out by itself and put everything to a power of 2. So I'm just going to go through what that process looks like that I have listed up here on this particular equation. To complete the square, I'm going to start by isolating the x squared and the x portion and moving this to the right by subtracting it. So I'm going to subtract 11. So this is my first step. I get x squared plus 8x is equal to negative 11. The second step was to divide both sides by a, the number in front of the x squared. Here that number is 1, so technically we can skip over this step. Dividing by 1 will do nothing to either side. If I look at the third step here, here's what we're going to do. I'm going to look at the number in front of the x term, which is 8. I'm going to focus on that. And I'm going to take half of that number, which is 4. I'm then going to take that number 4, and I'm going to square it, which gives me 16. I'm now going to add 16 to both sides of the equation. This is going to be one of those things where we'll have to look back and see why this is useful for us. But just to recap, the thing I just did was step 3. I got these two terms by itself. I took this number, divided it by 2, I got 4, and then squared 4 and got 16. And if I add that same number to both sides of my equation, I still get that the left side is equal to the right side. The right side is going to simplify to 5. But this side, by doing this, essentially what is a trick, will create a perfect square. This will work every single time if you go through these 3 steps. By that I mean, you can write this as x, in this case, plus some number, and you just have to figure out, well, what is that number? You want to put a number here so that if you square this thing out, you get a 16 as well as an 8 sitting here and here. The number that goes here has got to be 4. And if you think about it, if you square x, you get x squared. If you square 4, you get 16. And if you multiply 4 by x and double it, it gives you 8x. I'm convinced that this and this are equivalent. But just to take a step back and look at what we did, we took this equation with this x just hanging by itself, did a little bit of work, and now that x is gone. In fact, I can use that square root property to solve this equation. I believe we actually just solved this very same equation in the previous example. To solve this thing for x, I will take the square root of both sides. On the left, I have x plus 4, and on the right, I have is equal to plus or minus the square root of 5. If I now subtract 4 from both sides, I end up at my answer. X is equal to negative 4 plus or minus the square root of 5. So this is quite a lengthy process, and we're just believing that it works. I want to try it one more time just to go over these steps, where I put now a number that's not 1 in front of x squared. My goal is to solve this equation, but by using this completing the square method. So step 1, we got to get the x squared and x by itself, and I'll add 8 to both sides to do that. So by adding 8, I get 2x squared minus 12x is equal to 8. Perfect. But there's a problem. There's this 2 here, and for this process to work, I want this to be a 1. But that's simple to do. I can divide both sides by 2, and it will cancel this 2 and change it to a 1. So step 2, it's not trivial this time, but I'm dividing both sides by 2. That means 2 gets divided into both of those terms. X squared, 2x squared divided by 2 is just x squared. Negative 12x divided by 2 is negative 6x. And on the other side, I have 4. So this equation and this equation are equivalent. But this one is set up where you can add a number to both sides of the equations to create a perfect square. What is that number? I'm going to look at the number in front of the x term, which is -6, and I'm going to take half of that value, which gives me -3. I then take this number, -3, and I square it. I'm squaring the -2, and it gives me +9. It is this number that I add to both sides of my equation. And I claim that the left side is now a perfect square. The right side is just 13, but the left side has got to be something squared. In fact, it's got to be something x. I know it's got to be minus because there's this negative here, x minus something squared. Well, what would it be? There's only one number that when you put it here and square it would take you back to this 9, and that value is this -3. This equation is equivalent to this one, but this one, it's easier to solve because I can use the square root property, and that's exactly what I'm going to do next. I'm going to take the square root of both sides. The left side is x minus 3, provided that I put a plus or minus the square root of 13 on the other side. My last step is to add 3 to both sides, and I have my final answer of x is equal to 3 plus or minus the square root of 13.